All right, we want to find the half-life of palladium 100. Or no, sorry, the half-life of palladium 100 is 4 days. After 24 days, a sample of palladium 100 has been reduced to a mass of 5 milligrams. All right, so what was the initial mass in milligrams of the sample? Okay, let's go ahead and take a look at this, and let's write down some of the given information that what I just read right here. So the half-life. So half-life, and sometimes it really depends on the notation given in a given problem, but you can denote this one t subscript 1/2 is equal to 4 days. And then after 24 days, after t equals 24, t is defined as the number of days. Um, we have a mass of 5 milligrams. And we're interested in finding the initial mass. Let's see. Let's draw what we're trying to find. The initial mass in milligrams of the sample. And what is the, so we'll just focus on that. We're solving that right now. Let's not jump ahead. Okay. And the general formula for a problem like this, where we're dealing with half-life, is where we have exponential decay, which is where we deal with half-life, is A of t equals A sub 0, the initial mass, times 1/2 raised to the t divided by the half-life, t sub 1/2. Okay, so let's go ahead and see what we know based on what we have here. So A of 24, using the proper notation here, this tells us of A of 24, when we plug in 24 into the function, we'll have a mass of 5 using the actual notation of the formula. And t of 1/2, this, if we're writing in the proper notation, t of 1/2 equals 4, right? The half-life, t of 1/2. Okay. And so using the given information, we can plug in. So we have this formula here. We can plug it in below and get A of, so A of 24 is 5. So we're actually going to plug in, oh, 5. We're going to get an output of 5 when we plug in 24 into our function. So A sub 0 is what we're solving for. That's our unknown, the initial mass. So we're going to be solving for that. And we are given that, okay, we have 1/2, that was already there. And then we have 24 inputted into the function, right? Because as mentioned right here, 24 is inputted to the function for t. And t of 1/2 is equal to 4. I'm just plugging in what we are given in this function. So that piece of information and that piece of information plugged into our initial, or what we know about the function so far, just the general form, we end up getting what we have right here, if you don't see that already. Just plugging in that given information. Now we just have one unknown, A sub 0. And so we end up getting 5 equals a sub 0. Let's simplify this a bit. 1/2 raised to the 24 divided by 4 is 6. Okay, so that would give us 5 equals a sub 0. 1/2 to the 6 is 1 divided by 2 to the 6th power. 2 to the 6th power is 64. You can check that on a calculator, but it is 64. So times 1 over 64. And then we can get our a sub 0 is 5 times 64, which equals 320. You can plug that into a calculator if you'd like, but that's it. So 320 milligrams is our initial mass. That's what we've just solved for. 320 milligrams. I can put mg. Probably doesn't want the mg in there for our solution. Okay, and yeah, it says in milligrams. So you could just put 320. What is the mass 6 weeks after the start? Okay, well, we'll call this part B and this part A. So we've just this is all part A so far. Now on to part B. What is the mass 6 weeks after the start? 6 weeks. But notice that T is in terms of days, right? So 6 weeks gives us T equals 6 times 7 is 42 days. All right, and using the information we solved in part A, we have the function a of t equals a sub 0, which is 320, times 1/2 t over, oh, we know what t 1/2 is, and that's 4. Okay, so using this given information, we need to plug in 42 in for t and solve for the mass after 6 weeks. So a of 42 equals 320. 1/2 42 over 4. And we can solve for that. And at this point, 42 over 4 ends up being 10.5. And I wouldn't expect you to do this by hand. So a calculator will most definitely come in handy. You can always, on your exam, use a calculator, or just any activity. Use a calculator, preferably a scientific calculator. And we can do, we'll do 1/2, or you could just do 0.5, 0.5, 0.5. And we're going to raise that to the 42 over 4, which is 10.5. You could do that, but I'll do 42 over 4. All right, you'll get that, but we need to multiply that by 320. And we get our solution. All right, and where's my pen? Okay, that would be 0.221 approximately. Approximate. And that's in milligrams. Right? The units is milligrams for the mass. All right, so we'll put that in here. 0.221 milligrams. Probably doesn't want the units if you're inputting it into MyOpenMath. And that is our final solution. All right, let me know if you have any questions, and I'm more than happy to help. Just in this problem we're dealing with half-life, so you should know the initial general function we're dealing with that I highlighted in yellow in the top right there, and use the given information of the problem to start solving for what is unknown in the problem, and in this case the initial mass, and then use that to build your function and solve for what they're asking for in part B. That's all we were doing here. And yeah, please let me know if you have any questions. I'm more than happy to help.